So welcome to our convection lab. It's another way that heat can move from hot to cold. What you're looking at right now is a model of a solid. You can see all of those particles are kind of wiggling, but they're staying in the same spot. And conduction works for this because when the molecules start to move, they can bang into their neighbors. The problem is if your neighbors are mobile, like right now, that's a lot harder to do. You can't really bang into your neighbors. This is trying to show you an example of a liquid where the molecules still have to stay in a group, but within that group, they can move wherever they like. I used the analogy earlier of you and your friends at lunchtime can have to stay at your lunch table, but you can move around within that lunch table, and that is what this is trying to show. So this would be a liquid, and conduction isn't going to work here because, again, if you start moving, maybe the one that you're going to run into all of a sudden flies away. Now, this is now just turned into a gas. And as a gas, now you can go wherever you want. This is total freedom. But both liquids and gases have some freedom. So I want to come up to this because this kind of heat transfer requires some molecule freedom. And I'm going to go ahead and sorry I have to do this while the camera's running, but I've yet to figure out how to splice different movies in at the same time or into each other with this. At any rate, okay, here is a apparatus that's filled with liquid. And you can see I've got a candle going right here. And it's kind of sooty there, so I'm sorry, but heat is moving through this whole thing, but you can't really see it move. And it's moving because the molecules are mobile. But if I put a little bit of food coloring in this, all of a sudden, it'll trace the heat movement. So the molecules that are being heated are just these ones in the water right here. These ones aren't getting heated, but we are getting some heat transfer. And I'm going to put a little food coloring in here so we can see. Now, if I add that food coloring, it's going to come down here, and it's not going to go just anywhere. Notice it all goes to the right here, and it's moving down there. So we have got movement of the food coloring. Well, we're getting that same movement with the heated water molecules here because the heat makes them less dense, and less dense things rise or move. That's why hot air rises, which I know a lot of you know. So this is going to come down right here, and it's going to hit the flame, and it's going to get heated up. It's going to become less dense, and it's going to start to rise, and it makes a convection current. This is how heat moves through all liquids and gases. This is how heat moves through our ocean, and it's how heat moves through our atmosphere. It's how heat moves. It's one of the ways that heat moves through our room, and so there's any place where you have a liquid or a gas, because those molecules are movable, all of a sudden they can actually take the heated molecule, unlike with conduction where the heated molecule stays where it's at. If this was solid metal, the heated ones would stay right there and they would be banging their neighbors and passing that heat that way. This one's actually heating the molecule and having the heated molecule move. So here is our second way in the universe that hot can get through cold. In solids, we have conductions. In liquids and gases, because of mobile molecules, we have convection.